Most people talk about AI agents as if the model is the whole product. This article makes the opposite case. The real product is the harness around the model. The orchestration loop, the tools, the memory, the context logic, and the safety checks. In this video, we break down that argument, connect it to real frameworks, and keep one practical question in view. How do you make this work fully local, in the current setup, across the coding agents you already use? The hook is painfully familiar. You build a chatbot, wire up a React loop, add a few tools, and the demo looks fine. Then you try to ship something real. The model forgets what it did 3 steps ago. Tool calls fail silently. Context windows fill up with junk. Suddenly, the model looks much worse than it did in the benchmark. The article argues that this is usually not a model failure. It is a harness failure. That framing matters because it shifts the engineering focus from prompt tricks to the full runtime around the model. It also explains why teams using the same base model can get very different product quality. The cleanest definition in the piece is this. The agent is the behavior you experience. The harness is the machinery that produces that behavior. The article uses a computer analogy that lands immediately. A raw LLM is like a CPU. The context window is RAM. External storage is disk. Tool integrations are device drivers. The harness is the operating system. And the thing users call an agent is the application that emerges when all of that works together. That is why the line, "If you are not the model, you are the harness," feels so sharp. It compresses the entire argument into one sentence. Prompt engineering still matters. Context engineering matters too. But harness engineering is the layer that turns a smart model into a dependable system. Once you accept that framing, the rest of the article becomes a map of the real engineering work. First comes the orchestration loop, the simple but essential cycle of assembling a prompt, calling the model, classifying the output, executing tools, packaging results, updating context, and looping again. Around that loop sit the production components: tool schemas and execution, session memory and long-term memory, context compaction and retrieval, prompt construction, structured output parsing, state checkpoints, error handling, guardrails, verification loops, and sub-agent orchestration. None of those pieces is flashy on its own, but together they decide whether an agent can work for 1 turn, 10 turns, or 2,000 sessions. That is why the article keeps stressing that the loop is mechanically simple while every step inside the loop hides serious infrastructure. The framework comparison is where the theory turns practical. Claude Agent SDK is presented as a thinner harness bet. Trust the model, keep the runtime relatively dumb, and let the model drive. OpenAI's Agents SDK is framed as code first, with a runner model and explicit workflow logic in Python instead of a graph DSL. LangGraph makes the opposite bet, modeling the system as an explicit state graph with conditional edges, reducers, and checkpoints. CrewAI leans into role-based collaboration, where agents, tasks, and crews create a more social orchestration model. AutoGen, now evolving toward Microsoft's agent framework, treats conversation itself as the protocol for orchestration. Different philosophies, same core pattern. A harness still has to manage state, context, tools, and recovery. The article's point is not that one framework wins. It is that all serious frameworks converge on the same underlying problems. The 7 design decisions in the article are probably the most reusable part. Single agent or multi-agent. React or plan and execute. Aggressive context compaction or richer recall. Deterministic verification, like tests and linters, or inferential verification, like model-based judging. Permissive or restrictive permissions. Broad tool exposure or tight tool scoping. Thin harness or thick harness. These are not cosmetic settings. They are architectural bets. And the article argues that better outcomes often come from exposing fewer tools, verifying more aggressively, and keeping the harness just thick enough to recover from failure without smothering the model. This is also where the scaffolding metaphor works. Scaffolding is not the building, but without it workers cannot reach the upper floors. As models improve, some scaffolding may go away, but not the need for context management, state, permissions, or verification. The article becomes even more useful when you look at products and repos that make the harness visible instead of hiding it behind marketing language. Real terminals. Real work trees. Explicit session state. A launcher that treats different coding agents as interchangeable front ends on top of the same runtime concerns. That is the key practical takeaway here. The value is not inventing a new model. The value is making the runtime coherent, observable, recoverable, and testable. And that is why the article's closing advice lands so well. The next time an agent fails, do not just blame the model. Look at the harness. If you want to study this idea deeper, the source article links out to Anthropic's long-running Claude research, Buran Milaje's Scaffold LLMs essay, and open specs like Claude.md, Memory.md, and Agents.md. Those references all point to the same broad shift. Useful agents are not single prompts. They're systems. And if you care about making that system fully local in the current setup, while still working across the coding agents you already use, the links on screen are a good next step.